Hello everybody, this is Odd Job Entertainment, bringing you another art tutorial video today, and I'm trying out a new position for the mic, so hopefully this sounds good to you guys. When we were doing the Snowspeeder live stream, I realized that I didn't have a method for splitting a cube into 3 equal sections, or thirds along the vertical axis, and I was thinking about it and I realized it's actually a lot easier than I thought. So we're going to take a look at how we split it into halves and quarters and why that works. And it's actually pretty simple from a math perspective, which is why I have what I know many of you don't like to see, a graph. So let's go ahead and outline one of these subsets here. So let's say that this is the cube that we're working on, and I can go to a new layer so that this will actually show up a little better. Okay, so drawn quickly, there's our cube. Well, a cube, when viewing one face only, is a square. So if you were to look at a cube head on, you would see a square. And we know from looking at this, I'll pull out the ruler tool so that this is a little neater. We know that one of the properties of a square is that you can draw a line from corner to corner in either direction, and it's going to be the same length line, like so. This is also true for any parallelogram where our faces are comprised of right angles. So pretend that I outlined this. I know I didn't, but if we take two of these subsets within the graph and we go corner to corner in either direction, and if we then take the length of either of these lines, we will find that they are in fact the same. So when we are using the subdivision in our artwork, as we do down here, all we are doing is we're taking these mathematic properties of a square and turning it on its side, literally, to extend it into the 3D space. So when we use this kind of method, it splits the square into halves, which is pretty easy to see. Let's grab a 90-degree angle here. It gives us the very easy ability to split this up into halves in both the vertical and the horizontal axes. So pretty neat trick, and we use it a lot if you're using my method in order to figure out where your next cube should be. So let's move on to what we do in order to draw more cubes. As you guys know from following my tutorials, we would go down to layer 3, and then you line it up with one of your corners and the midpoint of your vertical axis in the back. And then if you draw through it, that tells you where the beginning of, or the end of, your next cube should be. Just like that. Well, why does that work? If we come back up here to our graph, you can see that that's what we've done with this rectangle. This rectangle is in fact two of these squares right next to each other, and they share a vertical axis that is the same height, and when you draw across that cross section, you end up going to that same point. This is one of the properties of these squares, and what's special about the square that makes it really useful for drawing these cubes is that we know that this section here is the same length as this section. Now if you have a rectangle that is twice that length, half of that is going to be a length of one of our squares, and that's essentially what we're doing down here, and that's why this works. But as you've seen in my tutorials, you'll find situations where it would be beneficial to have 3 cubes or the ability to reference in thirds. So how do we do that? And that's where I was running into a little bit of a hiccup. By the way, real quick, I'm going to show that this also applies if we go into force. So if we draw across the midpoint of 2 squares, like so, and I've shown this a couple times in the Snowspeeder video as well, so go ahead and check out that live stream if you want to watch a more extensive drawing being done from this. But I can predict that the back of the 4th cube is going to be right here. Now it's not going to be perfect, you know, so spoiler alert, don't hold your breath too much. But the reason why it's not perfect is not because the method is imperfect, it is because I, as a human being, am imperfect. And each time we draw a line, because it has a measurable thickness, we are accumulating an error that propagates as we get more intense into our drawing. But this is my prediction of where it should be. And so if we use the tried and true method that we know, we come here, right? We draw through the midpoints. We then put in a vertical line here. And you can already tell that it looks like it's going to line up. But just to drive that point home, we'll go ahead and finish out that step. So line it up with the corner, line it up with the midpoint, and then we see that it does in fact line up with where I predicted it was going to be. So as long as your squares have equal side lengths, you can actually multiply by 2s in that method. I don't know how helpful it is, because if you're using my method, you generally need to know all this in the middle information in order to accurately place your points, but you can do that. So now, what if I am trying to point out where a facet is on my drawing that lines up in my plan view a third of the way up along our vertical axis? How do we do that? Well, let's get a new color so that we can see this. And magenta ought to stand out. And let's bring that down here. That way I can reference it a little easier. It's actually really simple. If we can split things into halves and quarters by referencing a midpoint and basically drawing across a half, what happens if we involve 3 squares? What would that look like? So let's outline these real quick up in our graph. Okay, there we go. 3 squares, right? Well, what happens when we draw from corner to corner of this 3x wide rectangle? We see something pretty interesting happens. So if we were to take this length and compare it to the total, we would find that this is approximately 1/3 the length of this one. I say approximately because, again, I'm a human and I'm not perfect, and this has some measurable width, so it's not perfect either. But as far as spot checking it with your eyes are going to tell you that it's 1/3. We can also see that this line, because this is 1/3 of the total, is half of this, and this line is 2/3 of the total. So this is how we can get our reference to 1/3 in our vertical axes. This also works if you need a horizontal reference. You can do the same thing. You would just need 3 vertical squares, which I will quickly draw in like so. It would be like that. And then this would be a third, this would be 2/3, this would be our total. So in order to use that down in this view, we'd need to stack up 2 blocks onto this. But let's take a look at how this looks in our perspective drawing. There you go. So along this vertical axis, that's 1/3, 2/3, 3/3, or 1. This also applies to any other slope that you can draw in a graph. So let's say we want to do fifths. Let's pick a different color for that. This lime green ought to work. So we've got 1, 2, 3, 4, 5 cubes going this way. So 1, 2, 3, 4, 5. Here we go. So on a graph, it's pretty easy to see because we've got all these smaller squares that we're kind of ignoring. But I know that if we are doing a fifth, it should end up going through this point right here. And then, you know, if you've taken pre-algebra or anything like that, you should know why that is. And we see that it does, in fact, carry out. That's helpful to us with our artwork because if I needed to say that something was 1/5 of the vertical height of my cube, I now have a way to do so. Just to prove that point, let's go ahead and add on to our train of cubes here. So we add on like so. Okay, now we've got 5. So let's grab that color. All right, and there you go. In perspective, 1/5, 2/5, 3/5, 4/5, 1, or 5/5. So that's how you can get those more complex subdivisions. So anyways, I hope that this is helpful to you guys. You know how this goes. Like, share, comment, subscribe, do all the YouTube things. Let me know what you're thinking. And until next time, this is Odd Job Entertainment, signing off.